Hi everyone, welcome back to my YouTube channel. Today we are discussing on the top 15 frequently asked SQL interview questions and their answers. So let's begin our video. First question is, what is SQL? What are its types of commands available in SQL? So SQL, it is a abbreviation of structured query language, and it is used to manage and manipulate the data in relational databases, that is RDBMS. So what is SQL? SQL is just a language. So whatever is the data, whatever is your application's data which is stored in relational DBMS. So how do you manage and how do you manipulate your data? You cannot manipulate it directly in the databases, so you need one language to query the data whatever is present in your relational database, and how you have to manage and manipulate them. So that is why you make use of SQL. So it is a structured query language which is used to manage and manipulate the data, and it allows you to perform the CRUD operation. What are CRUD operation? It is create, we have read, update and delete. So this is the full form of CRUD operation. So it is helpful for creating, that is adding the new data; reading, that is fetching the data; updating means updating or modifying the existing data, or deleting the data from your databases. So let us see what are the different commands available in SQL. So we have different types. We have DDL, DML, DCL and TCL. So DDL, what is DDL? It is data definition language. So in DDL, what is the description? What does DDL do? It is data definition language, which is helpful for defining. In the name, it suggests that this D stands for definition, right? So it is helpful in definition of the DB objects like table or schema. So here we can read that it is helpful in defining the structure of DB objects like table or schema. And example of the commands which are available in DDL type, that is data definition languages: create. We can create the new table. We can alter the column, we can alter its name, we can alter its data type of the column. So that way alter command is useful. Then we have drop. So drop is used to delete the table, and truncate is used to drop all the data, all the rows of our table. So these are the commands available in DDL. Then we have DML. So what is DML? It is data manipulation language. Manipulation in the sense it is helpful in updating or adding some data. So it manages the data inside the tables. Yes, it is helpful in managing the data inside tables. So what are the commands available in DML? Commands available in DML are select, insert, update and delete. So what do you do by select? By select you are querying the data. Then you have insert. By insert you will add the row in your table. Then you have update. In update you can update or modify your data in the row of whatever is stored in your table. Then you have delete. You can delete the row entirely. Then we have DCL. DCL is nothing but data control language. It is helpful for accessing the control or giving the permission. So giving the access or the permission, and the commands available are grant and revoke. Then we have TCL. What is TCL? TCL is transaction control language, and it is helpful in managing the transactions. And what are its different commands which are available? Commands available in the TCL are rollback. We have rollback. It's rollback. And we have commit, and also save point is available in this TCL type. Now let's go to our second question, that is, what is the difference between delete, truncate and drop? So these are the commands available: delete, truncate and drop. We will see how it is useful. In the previous question we have seen that uh, in previous question we have seen that the drop and truncate come from DDL and delete comes from DML. So here also you can say first differences: delete is coming from DML, and other truncate and drop is coming from DDL type. This is coming, these both truncate and drop is coming from DDL. This is one of the difference. Then operation wise, what delete does: delete is useful for deleting the specific rows in the table by making use of where clause. So you have to add a where clause in the table. That is how you can delete one specific row. Can we roll back it? Yes, we can do the rollback. And does it affect this table structure? No, we are not changing anything in the table structure. We are just deleting the rows. So it does not affect your structure of the table. And how is the speed? Speed is slower. If you're deleting any row, its speed is slower if you're using the delete command. Then we will see truncate. It comes under DDL. and it is helpful for removing all the rows. That is, it resets your table, but it is available in ddl type, and this drop is also available in ddl type. So truncate is basically useful for resetting your table so that all the rows will get deleted. And can we roll back it? No, we cannot roll back it. Does it affect the structure? No, we are just deleting all the rows together, but we are not affecting any table structure, so there is no it is not affecting our structure. Then how is the speed when we make use of truncate command? It is faster. Then we will see our next command, that is drop. This also comes under ddl. And operation, what it does is it is helpful for deleting the entire table, so that table will only not exist now. So can we do rollback? No, we cannot do rollback. Does it affect the structure? Yes, because we are deleting the entire table only now, so there is no structure, there is no table. So yes, it affects the structure. And how is the speed? It is the fastest. We will see the syntax of how we can use. So if we want to make use of the delete command, we have to type delete, and then from which table? From employee table. And then we have to make use of where clause, that based upon this condition, where department is hr, based upon this condition you have to delete that particular rows from the table called employees. This is how we use the delete syntax. Then we will see truncate. With truncate, what will you do? You will just write truncate table employees. So what will truncate do? It is going to reset your table employees, so it is going to remove all the rows. Our drop command, for drop, our syntax is drop table employees. So what will see, you can see that both of the syntax are almost same for truncate and drop, but what drop does, it is going to delete your table itself. So next time you want to insert anything in your table, you don't have table, you cannot insert, you will have to create it again. So that is the difference between truncate and drop. And these are the syntax for delete, truncate and drop. Our third question is, what are null values in SQL? How are they handled? So null value is nothing but missing or unknown value. So for example, you have some 6 columns in a table, and you are inserting only 3 values. Then what will happen to next 3 columns? There null will be inserted by SQL by default. So null is nothing but, when is null present in your database, if you have not given any value yet for that row in that specific column, then null will be assigned in that row. So it is saying that it is missing or unknown value. That is when you get null value in SQL. And it is not equivalent to having zero or empty strings. Zero or empty strings is something which you are giving intentionally, but null is given in your row. It is stored in your data only when you don't have the value. You are not intentionally adding null, but if you have missed to add some data, or there is unknown value, then only you get null in SQL. And second point is, you cannot compare null with equals or not equals symbol. So with other values you can make use of equal symbol, but if you are checking for null, then you cannot make use of equals or not equals symbol. You have to always make use of is null, is. You have to always type is and check whether is it null, is null, or we can write is not null. This is how we handle our null values in SQL. So we can see the syntax here. In syntax, you can see we have to write select star from employees where manager ID is null. So this syntax is basically checking the employees who don't have their manager. So we are just going and checking all those employees. We are trying to fetch all those employees who are having, whose manager IDs is null. That is, they don't have any manager. So one thing you can observe here, we have not made use of the equal symbol because this will not work. You cannot compare null with this symbol. That is why we have made use of is operator here. Now we will see our fourth question. What is difference between the primary key and unique key? So we will see what is difference between primary key and unique key. Here we have first property, that is uniqueness. Uniqueness, you can see in primary key, it ensures uniqueness, but it also makes sure that there is not even a single null value present in any of the row. So in primary key, you can have unique value. There should be unique value, but it cannot have the null value. Whereas coming to the unique key, what happens in unique key, it ensures unique value, but you can have one null value. So once you have stored null at the first row, then again if you try to store the null value, what happens then again if you try to store same value null, it is not unique. If you try to repeat it, it is not unique, right? So one time you can store null, and then after that you have to store all the unique and different values. count per table. How many primary keys can we have in a table? We can have only one primary key in a table, whereas coming to unique key, we can have multiple unique keys in the table. And what is purpose? Purpose is primary key is helpful for identifying the entity or identifying the row, whereas unique key is helpful for preventing the duplicates. So for example, if I have to say, if we are having our employees and we want to check that their phone numbers cannot be same, obviously if we have multiple many employees, then their numbers cannot be same, their phone numbers cannot be same, so we can make use of unique key that all the numbers are going to be different. But the thing is, can we use that phone number as the identity to identify any employee? No, we cannot use that phone number, because in future they can change the phone number or anything can happen. How do we identify any employee? We identify employee based upon their email id, or we identify based upon their employee id. So employee id can be our primary number. And one more thing to remember here is, your employee id cannot be null, so there will be no employee who will be saying that my employee id is null. So that is why we can say that employee id is one of the example for primary key. And uh, there cannot be any null values, and it is useful for identifying the each row or identifying each employee. Whereas unique key, you can have null value and it is helpful for preventing duplicates. There can be multiple unique keys in a table, and here we will see the syntax. How do we make use of primary key and unique key? You are just writing create table employee, you are creating the employee, and then what are you doing here? You are writing employee id, which is of type int, and it is going to be your primary key. It cannot be null, and it is helpful for identifying the rows, and also it there can be only one primary key in the whole table. Then we have email id. Email id is obviously it should be unique, and here data type of that email id is varchar 50, so we can make use of unique key here for email id, and we can make use of primary key for employee id. Our fifth question is, what is the difference between inner join, left join, right join, and full join? So let us see what are the difference between them. First, we will see inner join. So how does inner join, what is inner join doing? It returns only the matching rows from both tables. So for example, if we are having two tables here, and we apply the inner join, that based upon some common intersections, we are supposed to get the value. Then whatever is there inside this will be written. This is called as our inner join. This is what is the result you will get when you apply inner join on two tables. Example, common intersection. Then we have left join. So it allows rows from the left table plus the matching rows from the right table. What does that mean? So if we are having two tables here, so matching, obviously you will get whatever is the matching that you will get, and you will also get whatever the whole left table. So whole left table you will get, and the matching things you will get. Example, you can say missing right. So what happens is, here you have all the values of the left, and you have the middle values. Whatever is left out, the right things which are not present, they will be assigned value null. Then we have similarly the right join. What happens in right join? If you have two tables here, you will get the common point, and you will get all of the things which are present in the right table. Then we have full join. So what join does? Full join, it all rows when there is match in one or both tables, so it is going to return you the rows where there is a match in one or both of the table. That is called as full join. So all data is combined. So you can say, if you have the two tables, then whole data, like all of the data of our table, we will get. We will see a example. How do we write? We can just write select e dot name, so first table. Then we have d dot department name, that is from second table. So e is for employee and d is for department. So e is our first left table and d is our right table. From the employees e, inner join, here we have made use of inner join, and we are doing inner join of e with what? With the departments table. On what? On the department id. So e will, every employee is going to have some department and department id, and in department table we will anyway have the department ids of those specific departments. So we are making our inner join based upon the department id. We will see our sixth question now. What is difference between clustered and non-clustered index? So difference between clustered and non-clustered index, we will see description wise. For clustered index, it sorts and stores data physically. So whatever data you are storing, that will be sorted and it is stored in the data physically. And storage wise, you can say data rows is equal to index. So data rows, whatever you have, is equivalent to index. And how many clustered index can we have in the whole table? We can have only one, because it is built on the, it is usually used with the primary key. Coming to non-clustered index, it stores a separate structure with the pointers to the data. So what happens in non-clustered index is, for example, if I have to give an example, what happens in clustered is, if you have your dictionary, in dictionary, all the alphabets, everything is already sorted, right? If you want to search like mango, M for mango, you directly go to M section. So that is the example of clustered index. So everything is stored physically and everything is already sorted. But with non-clustered index, what happens in a book, if you have seen, you will have a index page. In index page, everything is written that this topic is available in which page number. So that is how, in non-clustered index also, a separate structure with a pointer to the data is maintained. So this is the structure, where you have reference of every data and where they are available. So those datas you will be having in non-clustered index, and data rows separate. And there can be many non-clustered index in our table. Example, you can see how can we create clustered index. We have to write create clustered and then the index. And after that, you can see on employees, we are writing clustered index on the clustered index name. This is the name. So this is the whole syntax. Like clustered index, you have to write create the clustered index, then you have to write the name of your clustered index on what, on the employees on the employees table. And this is our primary key, employee id. So usually they are created on primary key only. Clustered index can be created on primary key only, and there can be only one clustered index. Whereas coming to non-clustered index, there can be many. And here you can see the syntax: create non-clustered index. First you have to write. After you have written that, then you have to give the name of your non-clustered index on what, on the employees data table, based upon what, department id. So this need not be primary key, this can be any key. That is how we create our non-clustered index. Our seventh question is, what is view and what is the difference between view and table? A view, it is a virtual table based upon the SQL query, and it doesn't store the data, it only stores your query logic. So it is a virtual table. View is a virtual table which is based upon your SQL query. We will see an example here first. So what are we doing? This is our query, which is a normal query, is that we are selecting the name, department from the employees where status is active. We want the employees whose status is active, and we want their name and department. So what are we doing? This is our normal query, right? And then we are creating a view, create view active employees as. So this after as we have written our query. So this active employees, this active employee is going to store the query logic, which query logic which we have written below. Then whenever we want to see the view, we can directly write select star from active employees. So this is what is written in the definition, that it doesn't store the data, it doesn't store data, but it is only storing your query logic. Here we saw that it is storing the query logic. And how can we access our view, we have seen. Now features between table and view, we will see the difference between table and view. Feature wise, we will first see the storage. From storage perspective, in table it stores the data, whereas view, it stores the query only, which we have seen in the example below. Then we will see based upon the modification. Yes, in table we can do insertion, we can update, and we can delete the value, whereas with view it is limited because it is not storing data, right? You cannot do multiple modifications. Then we will see performance wise. Yes, table is faster because all the data is stored physically, whereas view is slower because it is just a virtual table based upon some SQL query. So this is the difference between table and view. We will see our eighth question. What is difference between where and having? What is the difference between where and having? We will see for where, how is it used? Like where is used with the rows before aggregation. What can be aggregation? Aggregation is nothing but like writing grouping the data based upon some conditions. So if you want to use where, you do it before aggregation, and it is helpful for filtering the rows, and it works on the non-aggregated columns obviously. And then we will see for having, how does having works with what? It works after aggregation, that is after grouping, and it filters the group based upon some group. There is some filtering happening, and it works on aggregate functions. We will see a code example below. In code example below, you can see we are selecting the department and the count of those employees who work in that department where status is active. So you can see that before any grouping we have just applied the um, where condition, that we want the department and their count from the employees where status is active. So how many departments are there and what are the departments where from the employees table where status is active, and then we are doing the group by department, that we want to group by department. And we also want to make sure that count of those departments are more than 5, at least 5 employees should be working in that department. So that is what we have written here. This group y we have done aggregation and we have written the having after aggregation. You can see after aggregation we have written that for whatever aggregation we did just now, that is grouping of department, we want to check that the count of the department should be greater than 5, only those department you give. So what will happen, the department whose aggregation is more than 5, whose count is more than 5 plus for those department their employees should be active, only those results will be fetched here. This is the difference between where and having. We will see our ninth question. How do you find the second highest salary in table? How do you find the second highest salary in table? This is the simplest query how you can make use, how you can find the second highest salary in the table. First, what you have to do, you have to get the maximum salary from the employees table. This is simple example where we are just writing select max salary from the employee. This will give you the salary which is the highest. Then what you have to do, again you have to write select max of salary from employee where salary is great less than. So what are you doing, you're just getting the salaries one by one and you're checking that maximum of the salary, you want the maximum of the salary, so one by one salaries will come and then you're doing the comparison. Or you can also make use of like select salary from the employees where that particular salary is greater than, then you need not use the max keyword here, you can just write a greater condition. So there are multiple ways to find the second highest salary. These are the simplest one where you can write the max of salary and the salary should be less than the maximum of the salary which you have got till now. We will see our 10th question. What is subquery and what is difference between correlated and non-correlated subquery? So a subquery, it is a query inside another query we saw in previous question. So the second part which we saw was the subquery and it can return the data to the outer function. We will see an example here. So first we will see the non-correlated query description. It runs only once and results are reused. We can see here example, this is our non-related subquery. So select id from department, you are just selecting the id from department and then what you're doing, you're selecting the employee where department ids are matching with the department ids of the department table. So this is the simplest non correlated subquery. Now we will see the correlated subquery. In correlated subquery you can see it runs on the each row of the outer query. Here you can see the example. Here what have we written, here we have select average of salary from employee where department id is equal to e dot department id. What is e is coming from our outer query this. So there is a correlation between the inner query and the outer query. Our inner query is dependent on outer query and our outer query is dependent on inner query's results. So this is called as correlation. You can see now this e dot department id one by one it is going to change for every employee. This is e is nothing but our employee table, right? It will have multiple rows. So e dot department id for every employee one by one their department ids will be replaced here and then we are just getting the name where their salary is greater than the average salary. This is the example of correlated query. Then we have 11th question. What are aggregate functions in SQL and give the example. Aggregate functions in SQL are count, which is helpful for counting the rows. Then we have sum, which is helpful for having the total sum of the column data. And then we have avg, that is for average. Then we have min for minimum and max for getting the maximum value. Here you can see the example. Here we have written select department and average of the salary as average salary from the employees and we are grouping by department. So based upon based upon the department we will have different department groups and from those we are getting the department and their average salaries. Now we will see our 12th question. What is difference between char and varchar data type? So difference between var and varchar, there are three differences. First is storage. So in storage you can see for char there is fixed length. If you give here 10 then 10 will be its storage. It is going to have the static or fixed length. And coming to varchar, it is going to have the variable length, and that is either it can be decreased or it can be increased. So in storage, char takes are more storage, whereas varchar is occupying less storage. Coming to padding, pads with spaces. So suppose you gave varchar 10 and you are just storing a variable alphabet s, then what happens for the next 9 storage, next 9 blocks, what happens, it is going to get stored with empty spaces, which is waste of our storage. Whereas coming to varchar, there is no padding. If it is less, it is less, only that much amount of memory or the storage will be assigned to our data. Then coming to performance perspective, char is faster because it is faster for small and fixed, but it is not efficient because it might lead to more wastage of our storage. But yeah, it is faster because directly that much storage of the memory of the storage is assigned to our char. Whereas coming to varchar, it is efficient because of the variable size. Example, you can see name char 10, so you give 10 but you only stored 4 characters here, and then rest things is a waste of storage. So here spaces are uh, concatenated after John. Coming to varchar, you can see even if you have given that okay there will be 10 alphabet, 10 is the length of the varchar, but you stored John, then even the last spaces, they are like removed. There is no spaces extra, there is no extra spaces, so there is no padding, and it is the efficient way of writing or storing the data. Then we have 13th question, what is normalization, and explain the different normal forms. Normalization, firstly we will see the definition of normalization. It is process of organizing the data to reduce redundancy and improve the data integrity. So whenever we have our data, there would be so much of redundancy where we have same data, then we have duplicate data, we have written it in comma, and there is no relation. So to remove, like to organize it better, to reduce the redundancy and improve the data integrity, we make use of normalization. So what are different normalization forms? We have 1NF, 2NF, 3NF. So 1NF is nothing but no repeating groups and atomic values. So whatever multiple phone numbers you have, it can be stored like separately and not in a group. There should be no repeating groups. Then what is 2NF? It is 1NF plus there should be no partial dependency. Then we have 3NF. 3NF is nothing but 2NF plus there should be no transitive dependency. And there is last one, that is BCNF. It is the stronger form of 3NF and it handles some special cases. Now we will see our 14th question, what is transaction and what is difference between commit and rollback. So a transaction, it is a unit of work that executes completely or not at all, which is atomic, which is nothing but atomic behavior. So if you have any work, unit of work, it is either going to get executed completely or not. For example, if you're transferring your money to your friend, either your money is going to get sent or it will not be sent, it will get failed. So either there is transaction which will be successful or it will not be successful. You will get to know it. It is, there is no intermediate mode between success and uh, failed. So you will have clarity of whether it was successful or it failed. So that is called as transaction. And what is commit? It saves all your changes permanently, so you can commit whatever you have done till now. And rollback, it undoes the changes since last commit. So whatever you did just now, you can undo it. You can see the example here. We are beginning a transaction, then we are just writing update accounts, set balance as balance minus 1 where account id is 1. So for the employee, or for the transaction where account id is 1, you are subtracting a balance by minus 100 because that 100 amount was sent. Then what you are doing, this 100 amount was sent to some other account, right, which was sent to account number 2. So you are doing that update accounts set balance is equal to balance plus 100. So whatever was deducted from here, it got added in the account number 2, and then you can either commit or roll back. So either, if you do commit, it is either going to save all your changes or it is going to roll back. So if it is successful, it will be committed. If it is committed, it will be successful. If there is rollback, then there is some issue, there was a failed transaction. We will see our 15th question, what are constraints in SQL, and name the types of constraints. So constraints ensure the data integrity and validity in the table. So if you want to have any check or you want to make use of referential integrity, that is you want some foreign key, you want some primary key, and you want some kind of check or rules to be validated in your table, you can make use of constraints. So what are different constraints? We have, first is primary key. It uniquely identifies each row. It is helpful for uniquely identifying each row and example is employee id int primary key. This is how you define this. These examples are for the syntax. So employee id can be your primary key, so you have to write in front of that variable, you have to write that this is my primary key. Then we have foreign key, so it is helpful for linking the two tables. So you can write primary key department id, which is going to reference the id from the department table. So this department is basically your department table, and based upon what are you doing, you are referencing id of the department table. So you are just checking that department id of the current table is referencing the id of the department table. Then our next third constraint is unique, which stores no duplicate values. Yes, in unique nulls are allowed, and example is you can write here email, it can be unique. Next is not null constraint. Not null, it prevents the null values. So you can write name varchar not null, which means that name cannot be null. You have to give a value to your name column. If you don't give, you will get error, you will not be able to insert your data. Then we have check constraint. How do we use check constraint? It is useful for validating any condition, like check salary should be greater than 0. You can write a check that salary should always be greater than 0, or age cannot be greater than 100, or age cannot be less than 0. So such conditions you can write here. Then we have default. So what default does, in default we set the default values. For example, you can see below we have status varchar. We have status varchar 10 default active, which means that status either it will be active, inactive, anything. So we have status varchar 10, and in case you don't give anything, by default it will be assigned value active. So string value active will be assigned to your varchar. Yeah, we have discussed on all important 15 questions. So if you found this video to be helpful, then do give a like and subscribe to the channel. Also, if you have any suggestion or feedback, you can let me know in the comments. So if you want me to make video on any other topic, you can let me know in the comment. Thanks for watching, everyone.